Assalamualaikum warahmatullahi wabarakatuh. I'm Ahmad Nabil bin Halim with metric card number 220284 from section A14, and I'll be explaining about question 1A. Okay, question 1 stated that a nylon guitar string has a linear mass density of 7.20 gram per meter and is under tension of 150 Newton. The fixed support are at a distance d 90 cm. The string is oscillating in a standing wave pattern shown in figure 2. Okay, so question A asks us to find the speed of the wave. To find the speed of the wave of a string, we need to use the formula V equals to square root T over M, where V is speed, T is tension, and M is linear mass density, or we also call it as mass per unit length. So from the question, we have the info that T is 150 Newton and M is 7.2 gram per meter. So before we do anything, we need to remember to convert them to SI unit. For example, the M given in the question is not in SI unit, so we'll convert it into kg over meter by dividing it with 1000, and we'll get the value 7.2 times 10 to the power of negative 3 kg over meter. And then we'll just insert the values into the formula. So V equals to square root of 150 over 7.2 times 10 to the power of negative 3, and we'll get the final answer of 144.34 meter per second. And that's all for question A. We'll continue to question B. Izra, are you there?
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Izra bin Muhammad Zaini with the matrix number 221664, and I will be explaining about part B for question 1. Now, the question asks us what is the frequency of the travelling wave. With frequency value, we can use the equation V equals to F lambda, which is derived from the equation V equals to lambda over T. The equations is derived from two equations, which is K equals to 2 pi over lambda and omega equals to 2 pi over T. Now, we know that V is equals to omega over K, and after substituting the relevant values, we will get V equals to lambda F, which is the equation that we are going to be using for the part B question. The value of V, which is the speed of the travelling wave, has already been calculated in part A, which the values 144.34 meter per second. Now all we need to find is the value of the wavelength. In order to find the value of the wavelength, we have to divide the value of distance into 3 parts, as the diagram involve 3 parts of half oscillations. A wavelength is equals to 1 full part of oscillations. Therefore, we can use distance minus 1 over 3 distance, which equals to 0.6 meter, as the value of the wavelength. Now that we have both values of V and lambda, we can substitute the values into the equation V equal to lambda F in order to get the frequency of the travelling wave, which equals to 240.6 Hz. That's all from me. Thank you.
Hi, Assalamualaikum. It's me again. So, as a student of Islamic University, we'll of course need to relate physics to Islam. But there isn't a specific verse in the Quran or Hadith that directly mentions travelling waves in physics. However, the Quran often uses metaphors and descriptions of natural phenomena to convey spiritual or moral lessons. While there may not be an explicit reference to travelling waves, there are verses that discuss the natural world and the science of Allah's creation, which can be related to the scientific understandings of wave phenomena. For example, in Surah Ar-Rum, chapter 30, verse 48, it is mentioned, Allah is the one who sends the wind, so they raise a cloud, and we drive it to a dead land and give life thereby to the earth after its lifelessness. Thus is the resurrection. This verse highlights the process of wind carrying clouds to barren lands and reviving them. which can be seen as a metaphorical representation of the transfer of energy and the revitalization of an environment. Although it doesn't explicitly mention travelling waves, it signifies the dynamic nature of the natural world, which includes the propagation of various forms of energy, such as waves. So that's all from us. Thank you very much. Please like the video and don't forget to subscribe, and we'll see you on the next video.